So here we will have a look at another type of modifier for that re.search, that is wildcard. So by the term wildcard represent anything. Wildcard is anything. So and that is represented by character dot or a full stop, we can say. So this will try to match anything, say a special character or a letter or an alphabet, either it's a caps letter or a small letter, anything. This will come handy when we want to search a character starting with anything. So sorry, like say if I want to search a particular special character which I am not aware of, then we can use this dot operator or a dot character as a finding or a optimizer, or we can also say modifier for that search. So it will work the similar way. So I'm passing this character or a letter A as a input text and a pattern as dot. So let's see how does it will work. Yep. So it could clearly found that yeah, it is matching because it's a dot, it's a wild character, it can match with any character, but it will match only the first character. So suppose if I pass a word for this, some random word, JKSS, some random word, it will try to match only the first character. Yep, you can clearly see that yeah, I have found one wild character, that is J. You can add anything, literally anything. Let's say if I make it as a flower bracket or a closing bracket, yeah, it has found that. So it will find any special character or any alphabet, anything which is appearing at the very first. So this is how wild character works. What if we want to identify or search only particular set of characters? We don't want all the things to be searched. What if we want to filter out only the small letters or small alphabets, that is small letter A to Z? What to do then? We have another type of modifier for that search, that is character set. So generally a character set will be looking in this way. It will be consisting of uh, square brackets, a opening and a closing square bracket, and within this square bracket we will define a set of characters which we want to find. So this is how it will do. So print find pattern, and I am passing this text A or a letter A, and I am checking whether it belongs to the character set ABC, that is flower bracket ABC. Let's have a look at it, and we could clearly see that yeah, it belongs to that character set or group of characters, that is ABC. So A is a group of ABC, right? So that's why it has given me the result. What if I change this as D? So it could clearly show not found because this D doesn't belong to this character group. So it's just a group of characters. A, B, C is a group of characters, and I am trying to search whether D belongs to this group. Clearly it is not, right? So what if I want to search for a range of characters? Say if I want if I want to define this character set, say from A to M, I can't keep writing A, B, C, D, E, F, G, H, I, J, etc. Right? So I can just define that set of characters in this way as well. So A, this is a dash operator. A to C represent A, B, C. So it will try to search all the characters if it is appearing in this range. So this is the input text which I am passing, that is C. C is the letter is as an input text, and I am trying to pass this pattern, that is A to C. So now it has to search the characters which belongs to this range, that is from A to C. Yeah, clearly we could see that C belongs to this range A to C. So it is a range of characters or a set of characters appearing from A to C, and I am trying to search C in this. So what if I give A to Z? Even then it has to give me the result as found. Yeah, because this will fall in between, this letter C will fall in between letter A to Z. It is very case sensitive. This particular group of character is very case sensitive. So what if I give it as a capital letters? A to Z. Now, even though this C appears to be belonging from A to Z, since it is a case sensitive, it should throw me saying that it is not found, because it will take the ASCII values inside. So it will assign ASCII values for this particular character C, and clearly you could see that I am searching the letters which comes under capital letters from A to Z. Clearly this C won't be appearing. So for this, what I can see, if I change it to capital letter C, then it could clearly show me the result as match found. So that is how this set of characters or group of characters work. We can add another modifier on top of it. That is these anchors. We can add anchors on top of this group of characters. So you could clearly see that I have done that as well. So I should be searching for a character starting with A, and it should be appearing within this character group. So this is how I could explain this. So a cap is used inside a character set to indicate the complementary set. That is, it should return true if neither of these is present. That is either A, B or C, right? So it should start with A and it should be between A, B, C. So if so this is how it is a complementary it is saying. So uh, it's like a negation operator, or it is a negative operator. So it's just like defining this in an opposite way, right? So give me the result if it does not belongs to this character group. That is what this cap indicator acts as a complementary. That is what the thing is, complementary set. So this is a character set, right? So this is a character set which belongs to, but if I add a cap within this entire character set, then it will try to find the characters which are not which does not belong to this group. That's what the complementary means. So I could clearly see that if I pass letter A and I have added this complementary, then clearly A belongs to ABC. But since I have added this complementary, it is taking that instead of taking ABC, it is considering all the letters starting from D to Z, right? So instead of writing D to Z, I can clearly state cap ABC. So this will indirectly convert that cap ABC into D to Z, and it will try to find whether A fits in between D to Z. No, it doesn't belongs to that group. That is why it is throwing me the error not found. So this is one of the important aspect or modification of this particular character if we use within this character set. Apart, if we change this or if we remove this brackets, square brackets, then this will makes a different sense. What does this will do? It will try to search if it is starting with A. Yeah, clearly you could see this is a character, or this is a character which is starting with ABC. Is this starting with ABC? No, it is just starting with A. So to be making this very peculiar to find with starting with A, then I should remove A, B, C as well. So this is how the cap operator works, right? So that's how it is actually operating. So up with a square bracket it acts a different way. Without a square bracket it just acts as an anchor. So there are other character set as well to be used in general. So these are all like ABC character, then ABC, capital ABC. It's an entire range of characters, that is A to Z, which I already demonstrated over here. So small letter A to Z, capital letter A to Z. What if you want to include both caps and small letters as well? So that is also there. That option is also available. That is A to Z and caps A to Z. Finally, if you want to include only the numbers, then we can say 0 to 9. So I will demonstrate that as well. So if I write a number, say 9, and if I try to find it, it should show me not found, because I am defining a character set, right? So for this, if I write it 0 to 9, then yes, this this number 9 belong to this character or a group of numbers 0 to 9. Now I can write any number, say 100. What will be the result? Exactly, because it has found out the very first character, right? So that is how it could able to identify any number if I define this character set 0 to 9. So basically it will try to extract any number belonging to this character set 0 to 9. So it should be any number, say it is a crore, 10 crore, it should be either should be belonging to this character set only, right? So this number set only, right? It should be starting with either 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, right? So that's why it can able to identify any number in a text corpus. So these are all the character sets which are available, and we have other set of wild characters or meta sequences such as uh, reverse slash s, which indicates uh, like space, tab, new line, etc. Suppose reverse slash capital S indicates complementary of this. So suppose if you want to eliminate or remove all the tabs, space, etc., then we can use this reverse slash and slash and an reverse slash and an S will do the complementary of this. So if you want to remove the tabs, new line, extra spaces, etc., then we can directly use the reverse slash S. So this instead of using this 0 to 9, that is numeric set, we can also use reverse slash D that represent the same thing. Suppose if you want only the characters and if you want to exclude the numbers, then we can use reverse slash D, caps D, that will do the task of complementary of this. And there is another set of or most widely used meta sequence, that is reverse slash W. This will indicate to consider small a to z, caps a to z, 0 to 9, and then underscore. So it will try to include, or in other terms we can say, consider only letters, numbers, and underscore, and exclude all these. Exclude tab, new line, next line, etc., and try to consider only letters and numbers and underscore. Then we can use this reverse slash W, and reverse slash caps W will definitely do the complementary of this. That is, it is same as this reverse slash W is same as writing reverse slash small s. So these are all about character set and meta sequences, and by this we are ending the modifiers or the filter condition on top of re.search. So do you think only this the regular expression contains only this function? Definitely not. So there are other functions as well which are present within the regular expression, and that's what I am going to cover in the next session. The top 5 or 5 most important regular functions that we would be requiring most of the times. So the including that search, we will cover other types of functions as well. We will try to cover match, final, find, filter, and sub. So we'll try to explore these functions as well in the